Hello everyone. In the coming videos, I'm going to discuss molecular collisions in gases. Under this subtopic, I'm going to cover collision cross section of molecules, the exact meaning of collision cross section of molecules and its mathematical expression, collision diameter, definition and mathematical expression of collision diameter, how collision cylinder is created and what is its mathematical expression, and what is hit collision, what is miss collision, hit and miss collisions. Most importantly, collision number, mathematical expression of collision number, and how this collision number depends on pressure and temperature. Next, we will be discussing collision frequency, the definition of collision frequency, mathematical expression of collision frequency, and how this collision frequency depends on pressure and temperature. And whatever the collision cylinder created, what is the length of that collision cylinder, its mathematical expression, length of collision cylinder mathematical expression, mean free path, the exact meaning of mean free path and how it depends on pressure and temperature. With the help of length of collision cylinder and collision cross section, we can find volume of collision cylinder. So we need to understand the meaning and definitions of various terms, their mathematical expressions. In some cases, like mean free path, collision number and collision frequency, how they depend on pressure and temperature. Those are the things we have to learn in the coming videos. In order to understand those definitions, it is necessary to understand the assumptions first, because all these terms were defined and derived by taking some assumptions into consideration. Those are the assumptions first you need to understand, then only derivations will be somewhat easy. So what are the assumptions made? The first assumption is all the molecules travel through space in a straight line. For example, if there is a gas molecule, that gas molecule travels through space in a straight lines. That does not travel in wavy line. The molecule will be traveling in space like this, or like this, or like this. So all molecules travel through space in a straight lines, that is the assumption. And all molecules are hard, rigid spheres. All molecules are hard, they are like cricket balls, and they are rigid spheres. They are spheres. Whatever it may be the molecule, for example, it may be methane molecule or ammonia molecule, or it may be sulfur dioxide, PCl5 or SF6. According to the concept of chemical bonding, the shape of methane molecule is tetrahedral, ammonia is pyramidal, sulfur dioxide is angular, PCl5 is trigonal bipyramidal, SF6 is a square bipyramidal. If you see, none of these molecules is having a spherical shape. But while defining and deriving collision parameters, all molecules were assumed as spheres. They have a spherical shape. That is the assumption. And the reaction of interest is between only two molecules. That means there may be a situation where three molecules undergo collision, or four molecules undergo collision, or two molecules undergo collision. But only bimolecular collisions are considered, because molecular collisions where three molecules are participating, they are not impossible, they are rare. Molecular collisions in which four molecules are participating, that is also rare. Anything rare was ignored. So bimolecular collisions are considered while deriving collision parameters. And the next assumption is collisions are hit and miss only. So what is this, a hit or miss only collisions? If you see, the collision occur when the distance between the molecule is equal to sum of their respective radii. For example, let us take a situation. In that situation, the two gas molecules are present like this. There is another situation or another instance, the two molecules are like this. And if you observe the distance between the molecules, here this is the distance between the molecules, distance between the center of two molecules, this is the distance. Whenever the distance between the center of the molecules is equal to sum of the radii of two molecules, then that in that particular instance collision will take place, molecular collision occurs. For example, let us take the second situation where the two gas molecules are present like this and the distance between the molecules is greater than sum of the radii of two molecules. Therefore, in this instance, in this situation, the two molecules do not undergo collision. And that is about hit or miss collisions. So collision occur when the distance between the molecules is equal to sum of their respective radii. Collision does not occur if the distance between the molecules is greater than sum of their respective radii. So if the distance between the molecules is greater than sum of the radii of two molecules, whatever it may be, that in that situation molecular collision does not occur. That is another assumption. The two molecules do not interact in any way till they physically collide. For example, in this situation, there is here in this situation there is a molecular collision. Therefore, during this molecular collision, there is some interaction between the gas molecules. It may be transfer of electron, sharing of electron, whatever it may be, weakening of existing bond, whatever it may be. But if you take this particular situation, in this particular situation, there is no interaction at all between the gas molecules. The two molecules do not interact in any way, whatever it may be the interaction, till they physically collide. Once there is a collision, weakening of existing bonds, transfer of electrons, sharing of electrons, some kind of interaction will take place. And all the molecules travel with the same average speed. Every molecule is moving with the same average speed. Another important assumption, and this will be helpful while deriving collision number, collision frequency, and mean free path. And the last assumption, that is, even though the molecules would collide in all possible ways, only perpendicular collisions are considered. So let us understand. For example, this is the situation of two gas molecules. This molecule is moving like this molecule is moving like this. Now these two molecules are separated by an angle 180 degrees. For example, let us take another situation. This is the gas molecule and this is the another gas molecule, and this gas molecule is moving like this. This gas molecule is moving like this, and the angle of separation between them is 90 degrees. The two colliding molecules, whatever it may be the angle of separation between them, it may be 180, 120, 110, 45, 30, whatever it may be. But here, while deriving, they considered only perpendicular collisions, This is perpendicular collisions, and these are the assumptions. Let us see the behavior of gases. Whatever the assumptions we studied so far, you can understand all those assumptions here. So the molecules, various gas molecules, all are rigid spheres. They are moving only in straight lines. And most importantly, bimolecular collisions are considered. And whenever the distance between the gas molecules is exactly equal to sum of the radii, molecular collision takes place. And whenever a molecular collision takes place, you can observe velocity of one molecule decreases, velocity of another molecule will increase. And these are the assumptions. Those assumptions are very much useful to understand the derivation of all collision parameters. And irrespective of nature of molecule, you can see every molecule is a rigid sphere. Thank you very much.